This is Chycho again. Now, as I previously mentioned, what we're going to do now is learn a new technique of solving equations, quadratic equations, which are basically more complicated equations, one order of magnitude more complicated than just a linear equation, linear function. Now, we'll get into all that stuff and what they all mean later on when we go into coordinate geometry and we talk about more about functions. What we're concerned about in these next few videos is learning the techniques of factoring. And as I previously mentioned, there's 4 different types of factoring. There's a GCF, which is greatest common factor. There's a simple trinomial factoring, difference of squares, and complex trinomial factoring. And I use the 4-step method for that, but we'll get into that. And the reason we're learning all these 4 different techniques is basically because all of our equations are not just going to be simple equations where we can move around an equal sign just using the simple rules that we learn, and be able to isolate our x on one side with, equaling to a number or other variables, right? We're going to get more complicated equations. We're going to start dealing with more complicated functions. So the first thing we have to do is learn how to solve these more advanced problems, more advanced functions. And the first method, which is a general rule that you're going to end up using whenever you see whatever types of equations you come across, which is called the greatest common factor. So whenever you see an equation, what you're going to try to do is take out a GCF right away. And GCF basically refers to trying to find a pattern within different terms. So if you're given a multivariable equation or a function, what you're going to try to do is find out what's similar between each one of those terms and take it out of the equation and put it in the front. For example, if you had something like, if we go back to our prime numbers, let's talk about our prime numbers for a second, right? For example, if you had, let's do orange, 4 and 6. Let's say you had 4 plus 6. Now, if you had this, you would just add these up, and this equals 10, right? But one thing you can do with these is break these down to their prime numbers. So 4 would be 2 times 2, 6 would be 2 times 3, right? So what's similar between 4 and 6 is they both contain a 2. So what you can do is, instead of writing 4 plus 6 equals 10, what you can do is take out this 2 for both of these terms. So whatever's similar between them, you can take it out to the front. So what you can do is take out a 2 from this, and if you take out a 2 from this, you can take out a 2 from this. And when you take it out, it comes to the front of the equation. So that becomes 2. What's left here is 2 and a 3. And if they're added together, right? So what you do is you go 2 plus 3 is equal to 10, right? So 2 plus 3 is 5, times 2 is 10. That's the same thing as 4 plus 6 is 10, right? This is the basic principle, this is the basic idea of doing a GCF, taking out a GCF from an equation. Okay. Now, obviously we wouldn't bother doing this with something this simple, but what would happen if you had, for example, let's say an A here and a B here, right? Now, you couldn't just simply go 4A plus 6B. You can't add those. So what you would do is take out the 2 from both of them, and this would be 2A plus 3B, right? Now, this may seem silly to do, but this is something that we're going to end up doing to be able to solve equations, because we're going to use the property of 0, where it says if you're trying to, if you have multiple things multiplied together, for example, 2 things multiplied together to give you 0, then all you do, you set each one equal to 0. We talked about this before, right? So let's go find another wall, and we'll just move down a little bit and do another problem where, we're going to slowly mutate this thing, morph this thing into something more recognizable, so, it becomes more clear of why we end up doing this.